In this lesson, you'll see how you can use your knowledge of similar triangles to solve problems out there in the real world. And this is one of my favorite lessons in the whole unit, just because you can see how you can apply your knowledge to solve real world problems. So in example 1, we've got Paul, who's 6 feet tall. He notices that his shadow is 5 feet long. He then measures the shadow cast by his school building to be 30 feet long, and they want us to find how tall the school building is. And you can see that it would be pretty difficult to find the height of the school building by measuring, just because it's going to be so large, but we're going to use our knowledge of similar triangles instead. So I'm going to go ahead and start by drawing 2 similar triangles. And I'm going to draw a larger one and a smaller one. So I'm going to let X be the height of my school building. Buildings will form right angles with the ground. And then here's Paul. And you can tell my picture's not a great building, or not a great picture, because Paul is almost as tall as the building, and that wouldn't happen. But it just goes to show that you can be successful at solving these problems without having to be a great artist. So Paul's height is 6 feet tall. So I'm going to label the vertical piece on the second triangle 6. His shadow, and this is where you have to be a little careful, and you have to think about your knowledge about what's going on in the real world. Shadows always lie on the ground. So the ground is going to be my horizontal piece, and that's 5 feet long. The shadow, and again, the shadow will always fall along the ground that's cast by the school building, is 30 feet long. And again, our goal here, our mission, is to find the height of the school building. It might be worth mentioning that I know that these triangles are similar because somewhere up here is the sun casting its rays down, and the angle of those rays is going to be the same for both the school building and for Paul, making my triangle similar by angle similarity. So I'm going to set up a proportion. The height of the first object, the school, over its shadow is equal to the height of my second object, Paul, over Paul's shadow. And again, that is not the only way that you could set up that proportion. As long as you're cross multiplying, you're good to go here. So I'm going to go ahead and cross multiply, or as long as your cross products are the same, you're good to go. So 5x is 180, x equals 36, which means the school building is 36 feet tall. And I'm going to use the abbreviation for feet, or I can write out the word feet. And it's important to stop and ask yourself, is this a logical and reasonable answer? So 36 feet would be a reasonable answer for my question. So I'm relatively confident, relatively secure that I've done a good job here. You don't want to come up with a person that's 1.5 feet tall, or sometimes I've seen a question on a Regents exam where kids come up with like 270 feet for the depth of a pool. Just be cautious and make sure that your answers make sense. Number 2 is a similar kind of question. This time we have a child 4 feet tall casting a 6-foot shadow. At the same time, we have a tree nearby casting a 30-foot shadow. Find the height of the tree. So this is exactly the same type of question, except instead of a building, we now have a tree. And instead of Paul, we now have a shadow. Or sorry, we now have a child. But I'm going to do the same thing. I'm going to set up a couple of different similar triangles. If you're a nice artist, you can draw a nice picture of a tree. So the child, the smaller of the two figures, is 4 feet tall. That child's shadow, and again, that shadow is going to fall on the ground. The tree, X, is what we're trying to find, and the shadow of the tree, 30 feet long. So again, I'm going to go ahead and set up a proportion. Instead of the height of the object over the length of the shadow, this time I might compare the height of the child, 4, to the height of the tree, X, is equal to the shadow of the child, 6, over the shadow of the tree, 30. And again, multiple ways to write this proportion. The important thing here is that when you cross multiply, you're multiplying 6 times x and 4 times 30. So 6x is 120, which makes x 20, which makes the length of that, or the height of that tree, 20 feet. And again, it's reasonable to have a tree that's 20 feet tall. All right, number 3 also deals with feet in shadows. I happen to notice in this question that there is a typo. So if yours says 4 feet 8 inches, it should say 4 feet 6 inches. If you're not seeing the typo, it's probably because I fixed it before your packets were copied. So in number 3, it says a girl that's 4 feet 6 inches tall casts a shadow of 2 feet long. Nearby tree casts a shadow of 24 feet. How tall is the tree? So again, the same exact type of problem. What's different here is that this time we have a little bit of a mix-up in the dimensions because we've got this girl 4 feet 6 inches tall. So if I remember that in every foot there are exactly 12 inches, this is a total of 4.5 feet. And you should know that there are 12 inches in a foot. And it looks like all of the other dimensions here are given to me in feet. So my height of the girl, 4.5 feet, over her shadow, 2 feet. The height of the tree I'm going to call x, over the shadow of the tree, 24 feet. So again, I'm going to go ahead and set up my proportion. So the height of the girl, 4.5, over her shadow, 2, equals the height of the tree over its shadow, 24. So again, I'm going to go ahead and cross multiply here. So 2x's now are equal to 108, making x, the height of the tree, 54 feet tall. And that's a pretty tall tree, but still somewhat reasonable. All right, and in this last question now, we're departing a little bit from the objects and their shadows. This says a 12-foot ramp is used to load freight onto a truck. A point 3 feet along the ramp is 6 inches above the ground. How far above the ground is the upper end of the ramp? So I'm going to think about what it looks like when I load stuff onto a truck. I'm going to have a ramp that goes from the ground up to the back of the truck. So this is my ramp, so to speak. There's the back of my truck, or the height of my truck. The ground, of course, is going to be perpendicular. And this ramp is 12 feet long from end to end. At a point that's 3 feet along the ramp, so I'm going to put my 3 foot right here. That ramp is 6 inches above the ground. So again, if I want to think about that 6 inches in terms of feet, because again, I've got this mismatch here in the dimensions that are being used, that 6 inches would represent half of a foot. So I'm going to go back and I'm going to change my 6 inches to half of a foot, or 0.5. And it looks like we want to find how far above the ground the upper end of the ramp is. And I've got 2 overlapping triangles in this picture, and I remember from earlier in the unit that when we have 2 overlapping triangles, it's really helpful to draw them separately. So I've got 12 and x, and then I've got this other triangle where my dimensions are 3.5. So now it becomes a proportion just like all of the others that we've done. So x compares to 12 the same way that a half compares to 3. And again, how you set that proportion up isn't important as long as when you cross multiply, you're multiplying 3 times x and 12 times a half. So it looks like that ramp is 2 feet above the ground. All right, so there it is, folks. As always, my thanks, my deepest appreciation for your time and attention. You should spend a few minutes doing the check your understanding questions on the next side, and we'll talk more about those the next time I see you in class. All right, have a good rest of your day, everybody.